All right, in this video, guys, we're going to look at the end of 3.1 going into 3.2. So we're going to talk about a little bit of correlation, and then we'll talk a little bit about least square regression line. So last video, we talked about correlation. We had a couple characteristics, right, between -1 and +1, and stuff like that. Now, the question of this first question here is, which association is more linear? One with 0.5, one with 0.9. And while correlation is a measure of strength between two variables, right, it's not the end-all be-all. You can't just base everything on one value. So what we can say is you can't determine form only by using correlation. Like we said in the previous video, right, there's different graphs that are going to have high correlations. Parabolas, for example, have pretty high correlations, but we know that that's not a linear model. So R is a supplement for a graph, but it's never going to be a replacement. Okay, and one of the best things you can do, and you should try this on your own, is make a table for y equals x squared values. Okay, make that table and then do two variable stats on your calculator. So make like 0, 0, 1, 1, 1, 2, 4, 3, 9. And you get a correlation of like 0.9 something. So while R is a good measure, it is pretty limited. So we got to be careful. Does a correlation near zero mean an association is weak? Again, same answer as last time, right? We need a graph, right? It's a good hint, right? If you saw a correlation of 0, you could probably get a good guess, but you're going to need a graph, right? The combination of a graph and an R value will help with analysis. And this is why that first chapter that you guys did over the summer is so important, because we're going to be graphing everything, basically. Okay, and big thing here is correlation a resistant measure of strength? It is not, right? It is highly impacted by outliers. Okay, so if you have outliers in the data set, your R is going to get pulled in the direction of the outlier. Moving down, how do you calculate R? I'm going to give you the equation. Don't memorize this, please don't. You'll never really need this. But anyway, it's R equals 1 over n minus 1 times the summation of xi, so that's each individual x value minus the average, divided by the standard deviation of the x's, because you have two variables. You need two variables like a correlation. And then you have yi minus y bar over standard deviation of the y's. Okay, and while you don't need to know this equation, one thing I do want to talk about is, what do these things look like? This right here, I forgot to divide it, I signed. Okay, this right here looks like a z-score. Okay, this right here looks like a z-score for the y's. Okay, so all correlation is, you're just really doing a standardization process of your both your variables. Right, these just look like z-scores. Okay, I'm going to let you guys do the scatter plot, and so you can make that on your own, right? Label your axes, do all that good stuff, make a title. But I'm going to just type in here how to find, do correlation on a calculator. So type your data into list. Okay, make sure you label them at the top. then go menu, stats, two variable stats. Okay, and now we'll give you a bunch of lists. If you scroll down, you get an R value. Okay. Other things you can do to make a scatter plot, which we can kind of run through this in class in person too. Go press Control and the plus sign. Then go to Data and Statistics. Put the X on the X-axis. Y on the Y-axis. And that will give you a scatter plot. So that's pretty nice. You can use a calculator to do that. We kind of talked about all the additional facts in the previous video, so I'm going to skip that. Okay, least square regression line, what is it? Okay, it's an LSRL, and we're going to talk about a couple different things about this. We'll just kind of do a brief introduction in this video, and then we'll kind of go into more detail in the next video. So here we have a little scatter plot, and we have this line going through it. All right, and we got an equation for the line right here. Okay, so we got an equation for the line right there. So now it says predict the amount remaining for a can that has been tapped for 10 seconds. Okay, so all we have to do here, we're just plugging stuff in, right? So we're going to take this 10 right here, just plug it in right there. So then what you end up getting is you get 248.6 plus 2.63 times 10. Type that in your calculator, and you get 274.9. Okay, so you get the soda equals 274.9. And again, in this class, we're always going to talk about it, some context. So what does that mean? The amount predicted amount, so the amount predicted of soda left in a can after tapping for 10 seconds is approximately 248.6. Okay, and a couple things I want you to look at, right? So again, I talked about this as a predicted value, right? So we're not actually giving an exact value, and I said approximately 248.6, right? Again, this line isn't perfect, right? It's just the best that we can do, and so it's going to be approximately 248.6, but there is some error in that. Okay. You can do the next one. Predict the amount remaining for 60 seconds. How confident are you in this? So you can think about that. So do the same thing, plug in 60. And last two things I want to talk about in this video. What is extrapolation? And is it a good idea to extrapolate and interpret the slope and y-intercept? So extrapolation is using a set of data and a regression line, which is that line of best fit. Okay, we're going to call it a regression line for a prediction that is outside the interval of the explanatory variable. Okay, variable is used to obtain the line. So for example, let's say you're looking at height and weight of like high school students, right? And so your interval goes from like 50 inches to 65 inches or whatever it is, right? As soon as you start going below 50 and above 65, okay, you start the extrapolation process, right? You're outside the range of our data. However, this is often inaccurate. Okay, so the thing with extrapolation, and you probably saw this in 60 seconds, right? Like at some point it becomes just unreasonable to predict that far ahead because we're going to have limitations on our graph, limitations on our data. So it's one thing that make sure you know. Okay. Next one, interpret the slope, last thing, and y-intercept. So a couple things. Let me draw something first. So the equation that we use is y hat, that's called y hat because it's got a hat on it, equals a plus bx. That's your general equation for all linear regression models. Okay. Now, we say y hat because this y is going to be predicted. A is your y-intercept, B is your slope. And I'm going to type some stuff down here in a second to kind of go over that. But anyway, y hat. That is the predicted value of the response variable. Okay, so that's going to be your, whatever you predict is going to happen to the response. Your B value, that is your slope. Okay, the amount the response variable increases for every increase in 1 unit of the explanatory variable. Okay, and you're going to use that same wording pretty much every time. You're going to say for every 1 unit in your explanatory variable is going to lead to this happening in your response variable. Okay, so in the tapping one, you had a slope of 2.63 seconds. Okay, so, and your explanatory variable was the tapping time, and your response variable is the amount of soda left. Okay, so for every 1 second increase in the amount of time that we tapped on the can, right, we the amount of soda that was going to be left in the can is going to increase by 2.63. Okay, the amount of soda is going to, so again, for every 1 unit in the x, right, we're going to expect this difference in the y. Okay, that's how you're going to say all those when you interpret slope. That's what you're going to do every time. And your a value, this is your y-intercept. And this is the predicted value when x is 0. And here I want you to be careful, right? Sometimes this is useless information, right? So if I'm looking at height and weight of an individual, or I just did one which was blood pressure and blood pressure and sugar levels, right? If your blood pressure is 0, you're dead. So it doesn't make sense to have that sort of extrapolation. So just be careful when you talk about that, because sometimes it can be useless, and then you just have to mention it that it's a y-intercept, but we're not going to expect someone to have a blood pressure of 0. Okay, so that's going to be the end of this video. That gives you a brief introduction to the LSRL. We're going to talk about how you find this line here in the next couple of videos. But that's it for today, and I'll talk to you guys soon. Have a good one. Bye.